Well, hey gang, we're back with hopefully our final video series for our QSC TriCopter build. Now, at this point right now, where we all should be, is we've built our flight stabilization system, we've got our airframe all built, motors mounted, wiring run, our wiring harness, everything is all, we're getting almost ready to fly this little beast. The next thing we want to do though, before we hook up flight stabilization, I've taken off my props on all three of my motors. We want to make sure that our speed controllers are all programmed to the same settings. Okay, so with your shorting plug in, and no receiver is hooked up to this, I've gone ahead, like I said, I've taken my props off just in case, but with no receiver or flight system hooked up to it, we're simply going to plug it in and get power to it with our programming card. Oh, get it plugged in with our programming card in place. So when I plug this in, you'll hear all my speed controllers chiming, and I've just plugged up one of these speed controllers to my programming card so we can discuss some of these settings. Now, a couple of things you want to be aware of. If you're using the flashing light and beeping, well, this is with lights, but if you're using a beeping mode, you don't have a programming card, you're programming everything manually, then I would recommend hooking up each speed controller separately to a battery with the receiver and do them one at a time. But just be sure that you have all three speed controllers set to the same settings. Now those settings are, if you have a brake mode, turn the brake mode off. We don't need a brake mode on. We want them to freewheel if there's no power. Okay, for your battery type, I'm using lithium polymer. Some of the speed controllers out there have a nickel cadmium or a nickel metal hydride point. I'm just using LiPo settings because it'll auto-detect the LiPo cell count and it'll set the low voltage cutoff accordingly. And with this particular TriCopter, I know that once I start getting down to about 3.2 volts per cell, it's going to have a hard time staying in the air anyway, so that's my big indicator that I need to land and recharge. But you can go so far as to set it to nickel metal hydride settings and not use a low voltage cutoff. It's totally up to you. The cutoff type, we have two selections. Usually there's a soft cutoff and a hard cutoff, where when the battery hits low voltage, it kills the motor so that you have plenty of voltage left to run your control surfaces, your servos and such, like you would in an airplane. Well, I use a soft cutoff for mine. I don't want those motors ever cutting out on me in flight. So I use a soft cutoff, which means that once we start getting close to low voltage, it's going to want to land. It's going to start coming down. It's going to have a harder time maintaining a hover. So use your soft cutoff type. And for the voltage, I've got it set for medium because I think that on these speed controllers, I think if I remember right, medium cutoff was at about 3.1, 3.0 volts per cell. Anyway, you can use that at your own discretion. Start mode. If your speed controller offers you different start modes, set it to normal. In other words, normal setting is when you give it throttle, it moves. From a dead standstill, it starts up immediately. Do not use a soft or a very soft, like what's indicated on these Turnigies here. You want it to start as soon as you give it throttle. You don't want it to take time to spool up. Timing mode, we have three on my speed controllers. We have a low, medium, and high. Since these are low kV motors that I'm using, and we will be using these types of motors in all of our multi-rotor crafts, then I recommend you set up low timing, and that's pretty much it. Oh, finally, a governor mode. If your speed controller has a governor mode, turn it off. You won't need that. So, just make sure all of your speed controllers are programmed identically. Now the next thing we need to consider is, well, how do we want to mount our receiver and our flight stabilization system? Now there's really no wrong way to do this. There's a few things to keep in mind, but first off I want to say you can just mount your electronics directly to your airframe. There's nothing wrong with that. I like to protect my electronics a little bit. So what I've actually done is I've crafted this nice little 1/8 inch light ply box. And I got a little lid that screws down to it, and in doing it this way I can put all of my components nice and neat inside the airframe. I don't have to worry about anything getting wet or anything getting bumped. And I'm going to try to zoom in here and show you this. But what I've done, my lighting here is awful, I apologize. I've actually put a little hole in the side to bring my receiver and my wires out that I could put on my lid, and as it turns out, with a zip tie or two to keep the wires off of my electronic sensors, I should be able to keep everything inside of the box, so that's pretty cool. You're going to have to pay attention to the orientation of your accelerometer and of your gyro, and of course it doesn't matter your orientation for your Arduino board or your receiver, but lay everything out so that no wires are coming in contact with any of the sensors. You want them to be isolated from everything. I have just taken this light ply box, and on the bottom floor of it I've smeared, or I've actually dripped thin CA all over it so that it's nice and hard and smooth. And then I've just used this white 3M double-sided sticky tape to affix my sensors nice and flat. And you'll be able to get a good idea of the orientation from our documentation on allthingscrash.com. But that's one way of doing it. And so that I have room for my wires and so forth, I've put some little bosses here, just a couple little stacks of 1/8 inch ply to space off a 1/4 inch. I've glued those to the top of my frame, and then that will actually bolt right in place just like that. And works out really good. I've been doing this on several of my multi-rotor designs so far, and I really like it. Now, something else you might consider, a lot of the guys are doing this. Hey, here's just a CD case. How many of these do you have lying around? This one's a 50 disc. I would recommend something about half this size. It'll probably get you by, although there's nothing wrong with that. You could certainly use that. It just kind of looks funky. But you can take this and take the spindle off, maybe cut you a hole, and that's going to allow your wires for your speed controllers and your servo and your power wire all to come up right through the center of it. And then you can double-side sticky your sensors in place with your Arduino and all that. And then once you've got everything in, well, then you can just screw this down. Now, the way you're going to want to mount this, you're going to want to mount the base rigid to your airframe. So that may mean you want to take some scrap light ply and make some little bosses that you can screw the thing into. That's a good way of doing it also. And it's cheap, and it's, recycling materials that you have around. The good thing about using a CD case is that you're going to be able to see the status lights on your Arduino board, and you'll be able to see at a glance if the green light's flickering, it's in calibration mode, or when it quits flickering, okay, it's calibrated, it's ready to fly. When I seal everything up into a little box like this, that kind of kills that. But anyway, that's what you need to do next, is decide how you want to mount your sensors and your Arduino board and so forth to your airframe. Pay close attention to mount those in the right orientation, because if you don't mount them in the right orientation, your TriCopter is not going to fly. Okay, now it's time to start wiring everything up. As you can probably see here, I've got my Flight Stabilization System box mounted to my TriCopter frame, and I've got my wires coming up through the hole that I made in the bottom of this box. These are the wires going to my speed controllers and my servo and my power lead from my BEC. I've just pulled my receiver and its harness out of the way for right now, because I've got 4 female servo extensions here that are coming off of my Arduino board, and I don't know how well you can see on the camera there, but I've taken time to label each of those, what the ports are on the Arduino board. I've got a 3, a 9, a 10, and 11. So it's time to start plugging up our wires now. So first off, we'll start with number 3. That's going to be our yaw. That goes to our servo. And I know I didn't label it here, but I know this one is my servo. So I'm going to plug it up into place. My big old fingers trying to get in here in this little small stuff. Okay, and that's now plugged in. So your servo wire goes into number 3. Next up is our rear motor, and that's going to go into number 9. And you won't be able to see it at all, but I've got my servos here. I've etched into them with my X-Acto blade. So this is number 9. rear speed controller. Plug that in. Now, number 10 goes to the right motor. And I'll see which one there. I picked it up first time. So, plugging in my right front motor to number 10. And then finally our left motor goes into number 11. Now I've got one more wire here, and that's my power lead coming from my BEC, but I don't want to plug that into my receiver until I've got all these wires tamed. And I would recommend that you just pull the wires out of the way in whatever fashion works best for you, so that these wires do not interfere with our sensors, our accelerometer from the nunchuck and our gyros from the Wii Motion Plus. And I'm just going to plug in my power wire from my BEC, and I'm just going to put that in my auxiliary channel. And I can get it in there. And now I can tuck these things away, and I'm just going to use some double-sided sticky tape. And you may be able to see here, if I stick that receiver right about there on the inside wall, then none of my wires are laying on my sensors. And I'll probably put a zip tie around here and maybe a zip tie over here to hold these wires out of the way so that we don't interfere with the sensors. Okay, now that we have everything hooked up, everything's mounted, we're ready to establish whether or not our motors are turning in the right direction, and we're going to establish our throttle range. So I'm going to turn my transmitter on, and you can have the sticks in any position, it kind of doesn't matter, because the first thing we're going to do, we're not going to put our shorting plug in yet. We're just going to plug in our battery, and that's bringing juice up to our switch from the main battery and then going out through the BEC and onto our Arduino board. Or it's actually going to our receiver, and then it's transmitting power to our flight stabilization system. So we can turn this on, and our receiver is hot now, and we're going to see a little green light. I would zoom in on it, but then the camera's on a tripod. You're going to see a little green light on your Arduino board flashing, and that basically is our status light, and it tells us that the system is booting up the program. As soon as that green light goes out, the program has been loaded and it's ready for our next step. Now, just a word about this first. When we plug in our shorting plug into our harness to bring power to our speed controllers and ultimately to our motors, we want to be sure that that the motors are armed. And the way we arm our motors, and I'm not going to be able to show you on camera, but we bring our throttle stick all the way down, and then we hold it to the right until we see our green light come on. And I see the green light is on the Arduino board, so that tells me the system is armed. So now I'm going to go up to full throttle on my transmitter, and I'm going to flip this thing over because good old Crash didn't bother putting this shorting plug anywhere convenient. So I'm plugging it in, and I can hear my speed controllers all arming. Now I'm just going to let them go through their routine. Now once they've all done that, we're ready to establish what our throttle is going to be, our throttle range. And they're just going to carry on, but that's okay. What we're going to do now, watch this transmitter motion. Once the motors are singing to us and they've gone through the main series of beeps, we can bring this stick down and to the left. And watch how I do this. I'm going to go down and to the left, just like that. And I'm going to hold it there until my motors quit making noise. And basically now we have established our range, our throttle range. Now by going down and to the left, I've told it that off is down, or the lowest possible throttle setting is down, and to the left is how we disarm our motors. Now if I want to arm the motors, I've got it down. I can hold the stick to the right until my green status light comes on. And if I had the system configured correctly, well then my motors would be spinning, because at our lowest stick, after the motors are armed, we want these motors, all three, idling. Now if we advance the throttle up, we can see that the motors are turning, and I can just very carefully put my finger on the bell to make sure that they're all turning counterclockwise, and in this case they are. So I know that I've got my direction set up. If I go with my throttle all the way down, I'm going to push it to the left, and that disarms the system. So we've learned a couple of things. I can go ahead and unplug the shorting plug, and I can turn off the flight stabilization system. And remember, our transmitter always goes off first on, last off. But now that tells me, since when I armed the motors they did not start turning, our lowest, when the motors are armed, our lowest throttle stick, they should be idling. All three should be idling. So that tells me I need to load up the Arduino IDE, hook up my FTDI cable to my board, and then bring the minimum throttle value up to something higher than it is right now. I know with these motors, my minimum throttle, and these speed controllers, my minimum throttle value is usually around 1320 to 1350. So I'm going to hook up my computer and I'm going to flash that and show you how that reacts when I'm finished. Okay, I've gone into my program, my Multii-Wii copter program, and I've loaded it up, and I saw that I think the default value for minimum throttle was at like 1120 on mine, on my copy. So I've changed it. I just changed it arbitrarily to 1370. And I've got the system powered up, and if I arm the motors, remember we take our throttle all the way back and then we scoot it over and let it go, and now my motors are armed and they're just sitting there idling. That's disarm. That's how we want that part done. Next up, we're going to talk about the configurator and setting your throw rates. Okay, I'm just going to keep this section rather brief. I've got everything plugged in. I do not have the shorting wire plugged into the wiring harness because I want the speed controllers dead for this exercise here. But I've loaded up, my FTDI cable is hooked to my laptop, and I've loaded up the version 1.6 configurator. If I go to the upper left hand corner, I'm going to hit COM3 to activate that COM. And then I'm going to come down to where it says Start. And now I can see a steady baseline because, well, the system is sitting perfectly still. If I look at my servo movements, I can see, like, for instance, roll. In the left-hand side of your screen, I see my roll at the far left is 1006. When I go all the way to the right, I'm at 2014. You want to adjust your throw values. You know, you have not 100%, but, you know, I've got this radio set up at 125% on both endpoints through my ATV settings. And I want to just check all of these things. And I can see here, if I go full throttle or full pitch forward, I'm at 2026. All the way back, I'm at 1016. That's pretty good. Throttle minimum is at, where is it at here, is 989. If I go full throttle, I'm at 2014. Again, for all of these motions, you want to be at a minimum of about 1,000, slightly less, and a maximum of about 2,000, thereabouts. And you can play with it to figure out what you want to do. But at this point, I can see that my system is working pretty well. So I am ready to fly. I'll talk about one more thing here shortly. Okay, our final notes before you go out and fly this thing. First off, your sequence of startup. Always, you know, because we're using a shorting plug and because we're using a switch and a BEC, you can go ahead and plug your battery in, leave it plugged in until you're ready to fly because nothing is being drawn from it. So always, turn your transmitter on first. Once that's on, now you can turn on your flight stabilization system. Remember, the green light on our board is going to be blinking while it loads the program. And then finally, once everything has been loaded, you're ready to put in your shorting plug, arm your motors, and go fly. However, something that I recommend that you do every single time when you plug power into it. What I would get in the habit of doing is, to arm our motors, and I'm not going to do it here now with the system on. To arm our motors, we go down and hold to the right. Our green light comes on our board, and the motors are armed. To disarm, we go down and to the left. Okay, but before you put your shorting plug in, have your motors disarmed. You don't have the shorting plug in yet, so it's probably okay, but I would go ahead and disarm them. Take both sticks. Take your right hand stick, go down and hold it there. Take your left stick, it's at low throttle, and now go to arm your motors, or disarm rather. But what that's going to do is that's going to leave your TriCopter perfectly still. Don't touch it, don't move it, make sure it's sitting flat and level. That forces a brand new and fresh calibration on your accelerometers and your gyros. And if you watch your green light, it'll flicker, 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 and sometimes it's 10, 12, even up to like 15 seconds. But when the light goes out, now you're ready to put in your shorting plug and stand back, arm your motors, and off you go. Remember also, this is a rough starting point. It's going to be kind of hard to see, but that is roughly where I'm starting. And remember, when we go to trim this thing, I recommend don't go more than 2 or 3 clicks of your trim. If it takes more than 2 or 3 clicks of your trim to bring the yaw in to make it stable, then immediately what I would do is power your system down, and I would make an adjustment here on our adjuster. But that's probably a very good starting point for me. And I think this is going to conclude the QSC TriCopter build for this year's Crashes Scratch Build Club. I hope you've learned something. I hope you've enjoyed it. I hope I haven't bored you to death. And my gosh, keep following the Crashcast, my podcast, and keep watching allthingscrash.com, my support site. You never know what we're going to get into next. And gosh, who knows what next year's Scratch Build Club is going to bring. Thanks for watching, guys.